Well, folks, we're going to pick up where we left off. In the last one, I was troubleshooting this issue where my copter didn't want to take off and was kind of yawing weirdly. Anyway, if you haven't watched part 1, go ahead and watch part 1. It's going to be linked down in the video description. And if you have watched part 1, here's part 2. Enjoy. Okay. So the question that we have to answer then is, why does the gyro think that the copter is yawing to the right? So here we are in Betaflight Configurator. I've got the copter plugged in, and the first thing I'm going to check is to see whether the 3D model is rotating on the yaw axis. Of course, the copter is just sitting here on the desk. It's not rotating, and if the gyro was in some way messed up, we might see rotation here on the yaw axis when none was present. Some of you might be saying, wait a minute, the 3D model is based on the accelerometer, not the gyro, and I know that because if you turn off the accelerometer, then the 3D model will stop working. And that's true, yes, but it's also not true. The accelerometer is used to update the position of the copter internally, but the real-time updates are actually from the gyro. And so basically, I don't know the actual frequency, but perhaps you'll read the accelerometer 10 times a second, but you're reading the gyro every loop, and you basically are doing dead reckoning with the gyro, which is then error is corrected by the accelerometer. And in fact, the yaw axis is always the gyro. There's no acceleration on the yaw axis. It's just pivoting around a point. So anyway, the fact that the 3D model is not rotating on the yaw axis, right? No, it's definitely not. That's just my hand moving. Yeah, that tells us that the gyro sensor is basically okay. We can also enable expert mode and go to the sensors tab, and we can look at the lines here, and we can see that the z-axis there's some vibration, of course, and that's normal, but there's just nothing going on there. So the sensor is basically fine. And that makes me wonder if there is a vibration that is causing the gyro readings to be misread somehow, and we're getting some kind of a sampling error, aliasing, that's causing the gyro to, because we saw in Blackbox, the gyro goes positive. And it definitely didn't do that. I mean, I just raised the throttle. The copter's not yawing. It's not even off the ground yet. So I gotta think that this positive gyro is an error. All right, guys. Well, now I'm going to do the very dangerous thing that you should never do, but I can't think of another way to troubleshoot this, so I'm going to do it. I'm going to hold the copter down, and I'm going to arm it. I'm going to watch the 3D model and see what happens. Because, I mean, it's one thing to see Blackbox, but I don't know. I want to see the 3D model move. Anyway, here we go. And I wonder if I just let it, I mean, we're at min check now, so the PID loop should not spin up. I wonder if I just let it idle here, will we see a cumulative effect on the 3D model? It's not, we didn't get any cumulative movement though. It didn't drift. It was wiggling all over the place, but it didn't drift. So let's try this. Let's just try that. Let's set the gyro soft filter to 50. That is a really low value. Let's try it. And we need to power cycle the board for that to take. You can't, if you change your gyro settings, it has to do a calculation on startup. So we have to power cycle the board. If you're tuning your gyro filters, you must power cycle the board in between each change, which has made for some frustrating tuning sessions when I didn't know that. Because I was like, no, everything, all of my changes don't do anything. It doesn't look much better. Let's give it a go and try to fly it. It's not going to work, but let's give it a go. Well, guys, I'm really stumped about this one. I flashed it back to CleanFlight 1.12. I tried different filtering in Betaflight. I tried changing the loop time. I don't think the issue is between the ESCs and the motors, because the motors spin correctly. They spin correctly in the motors tab, and they appear to be spinning correctly when I actually try to fly. I checked the endpoints and the calibration in BL Heli. Maybe one of the motor endpoints was not correct. But here's the kicker. Here's the kicker for me. The problem, or the symptom, if you will, is that the front left motor is not spinning up. It's not making thrust. And everything else the copter is doing is a result of that. And when we look at the PID loop, we see that that motor is at 0. The PID loop is commanding this to happen. And so if we were to conjecture that this was a mechanical problem with the motor, the prop is loose, the ESC is not going to full throttle, there's a timing issue, and the motor is not spinning as fast as it should, all of those things would result in the motor trace going to maximum. Because when a motor makes less thrust than the PID loop needs, the PID loop asks for more thrust, and the motor ends up going to maximum. So the fact that we see that this motor trace is all the way at idle tells us that the PID loop is commanding this to happen. And the PID loop is commanding this to happen, but it's clearly not the right thing to happen because the copter isn't flying. So the PID loop is getting bad data. The PID loop believes that the copter is moving, it's yawing right, it's rolling right, or it's pitching back. Some combination of those things. I believe the problem is most prominent on the yaw axis, I think, because that would result in this motor spinning down, but the other motor's working normally. If it was roll, it would result in both of the left-hand motors spinning down. If it was pitch, it would result in both of the front motors spinning down. So here we've got just the diagonal, just the front left motor spinning down, and that's yaw makes 2 diagonal motors spin down, but yaw doesn't affect the other axes. Anyway, so I think it's the yaw axis. It feels like we have bad gyro data coming in on the yaw axis. Well, at this zoom level, we can see the PID sum is correctly responding to the gyro. Why is it only here that it just falls off a cliff? The gyro seems 0, but RC command yaw is pushing to the right. The copter is yawing to the left here. None of the motors go to max. If there was a motor problem, one of the motors would max out, but it's not. What the That's really fucking strange. I give up. And I did, in fact, give up. I was late at night. I had been trying to solve this for a long time, and it was just making no sense whatsoever. But I'll tell you what I ended up doing and what ended up fixing it. The gist of this troubleshoot is it really actually boils down to something pretty simple, although it doesn't seem that way, and certainly didn't seem that way at the time. The gist is that the gyro is telling the PID loop that the copter is doing something that the copter is not doing. This is then, the PID loop is responding to this bad data with the correct response. So one of the troubleshooting techniques that you can use, and this applies to many things, not just quadcopters, is ask yourself the question of who's misbehaving. Well, the copter is misbehaving because it won't take off and it's yawing to the left because that front left motor is spinning down. But when we look at what the PID loop is doing, the PID loop is correctly responding to the gyro data that it's seeing. The gyro is telling the PID loop that the copter is yawing to the right. RC command is centered. If the copter is yawing to the right, but the stick is centered, the right thing to do is for the PID loop to push the copter to yaw to the left to counteract the uncommanded motion. So the PID loop is not at fault here. So what is at fault is the gyro. The gyro is giving bad data. And I tried all sorts of things to try to figure out what was causing the gyro to give bad data. Was it vibration? That's why I took and I filtered just the heck out of it. If there's some kind of weird vibration that's causing this, we could filter it. I tested it with a 3D model. I tried all the things I could think of, and at the end of the day, I concluded that the board itself was damaged in some way. and I replaced the flight controller, and the copter flies again. So in some way, the gyro became damaged. Hard to imagine how. This freaking board was brand new. It couldn't have had more than 30 minutes of runtime, maybe an hour of runtime, and was barely flown. But somehow or another, it started giving bad gyro data. As soon as we armed and started raising the throttle, the yaw gyro started reporting that we were processing to the right. And then everything else went to heck from there. The front left motor would spin down because that's how you get left yaw. And then the whole copter won't take off because the front left motor is at idle. And if the front left motor can't spin up, none of the motors can spin up, and you can't fly. Anyway, so as sort of lame as it sounds to say, well, it was a bad gyro, I replaced the board and it was fine, I hope that taking you through the whole troubleshooting process, it was still very valuable to you, because it's such a cheap answer to say, I don't know, must be a bad gyro, I guess I'll replace the board. And I tried to find literally everything else it could be before I came to that conclusion. So if you're running into a problem like this, you can follow these troubleshooting steps, and hopefully you will find the problem before you get to the end. Concluding that you have bad hardware is kind of just the last resort when you can't find any other solution. Anyway, there you go. That is the end of this troubleshoot. I hope you enjoyed it. I hope you found it very educational. I found it incredibly, incredibly frustrating and discouraging, and you can hear in my voice when I finish, I'm just like, oh, forget it. I'm going to bed. I want to throw this thing out a window. Don't buy the Eachine Falcon 210 for many reasons. Happy flying.